We cool?
Cool.
We're on. Okay, camera girl Nicole has taken over for Diamond Dave, the love slave. He had to go pick up his wife and kids, if you know what I'm saying. So, Nicole's here. Say yo, Nicole.
Yo.
All right. Nicole's cool. And she's cute. So, if we get her on the camera here today, you'll be totally stoked, all right? This is one of my daughters. If you ever try to look her up on Instagram, I'll come and kill you. Okay, so check it out. Talking to you boys. All right, so we are on part 2 of the review for our Chapter 4 test. All eyes up here. Okay, we got 4.2. We are talking about scientific notation on this test. We've already gone over the laws of exponents. There are 3 problems on the test dealing with scientific notation. Okay, again, most of the time I do not give you all these examples. I'm not going to go over all these with you. The answers are all circled in pink. Okay, I just want to quickly go over this with you. One problem asks you to put a problem into scientific notation, okay? All these little dots here really don't belong there, okay? And if you remember, we moved this 1, 2, 3, 4, 5, 6 places. That's where that 6 comes from. This original number is less than 1, so that's going to be a negative. And we have 6.98 times 10 to the negative 6. Okay, same kind of a concept here, all right? You may be asked to take something into scientific notation or put it out of scientific notation. You've got to review that concept. Very large number here. We move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. There's that right there, 11. It's positive because the original number is greater than 1. 1.03 times 10 to the 11th. Work those out. If you have any questions about how to do these problems, get online. You know, the chat tutoring or the one-on-one tutoring is available to you. We sent out an email a few days ago about all of that. You got this problem right here, and we've talked about this, how we take the number with the number, okay, and the base 10 with the base 10. And so if you work this out, okay, you divide these two numbers on a calculator first, and you're actually going to come up with 0.9178, okay? And then 10 to the negative 5 over 10 to the negative 15, again, that's going to be 10 to the negative 5 minus negative 15. Okay, maybe that pink isn't going to work out for you, so I want to do it in black here. So we have 10 to the negative 5 plus 15, which makes 10 to the 10th. And that's where we get this down here. But because that decimal is here, we needed to move it one place, get it into scientific notation, which took away 1 from there. I'll let you guys work that out on your own. You may or may not have to negotiate the final number on the test. It may be in scientific notation. But remember, if that decimal, look at this, if you have 0 point that's not in scientific notation because you can only have 1 digit to the left of the decimal, and that digit cannot be 0. We covered this quite a while ago, so remember to cover those things as you review for the test. Okay, polynomial basics, section 4.3. There's 2 problems from section 4.3. Evaluate the polynomial when x equals negative 2. I do want to show you one thing here. You guys can do this on your own, but negative 2 to the 3rd is negative 2 times negative 2 times negative 2. When you multiply that out, that's negative 8. Negative 8 times 3 makes negative 24, okay? I'm going to let you finish this problem out on your own. The answer is negative 30, okay? Again, if you need help with that, you can get on chat and get some assistance. Last problem, not in the entire test, just in this portion of the sections here. 3x to the 3rd minus 12x to the 4th plus 8x to the 3rd minus 7x to the 5th plus 8x to the 4th. They're telling us to collect the like terms and write this in descending order. Remember, descending order is by degree, 5, 4, 3. You know, you got a 3 and a 4 and then a 5 down here. You're going to have to invert that. Combining some like terms, you know how to do this. I'm going to let you do this on your own. Go ahead and pause it, Nicole.
Ready.
Ready. Fetchers of America, what is up? Nicole wants to speak some Spanish to you today. Did you want to come up here and say habla español? Loquísimo.
Here, I'll say this. Profe Llewellyn es muy estúpido.
Oh my gosh, get out of here. Okay, well let's hope I'm not too stupido or we're all in trouble right now. Okay, reviewing for the test. Section 4.4. Addition and subtraction of polynomials. You've got 2 problems. If you remember, when we add and subtract polynomials, we distribute parentheses, then we combine like terms. Again, folks, I'm not going to do these problems with you, save maybe one that I want to show you something on, but here are some examples. You've got the addition of one polynomial plus another polynomial. Here you've got the subtraction of one polynomial minus another. If we remember the subtraction, we do not need these parentheses. We can combine these like terms. There's the answer. You want to do that problem on your own after you pause. You can do this problem. This subtraction has to go to here and here and here, and you change those signs, and that'll be your final answer there. In section 4.5 and 4.6, they really make an emphasis on the multiplication of polynomial problems. There are 5 problems that you're going to multiply polynomials with. You're going to have one mono times any poly. There's a monomial times a trinomial. You have a problem like that. A binomial times a binomial. There they are, the binomial times the binomial. Remember, what is written in between here? Nothing. So we know multiplication is taking place. Draw your eyes back over here. Written in between, addition. Written in between, subtraction. What's written in between those parentheses dictates what you're doing with it. Okay? And then there's 2 problems like this. And this is one that I'm going to do with you because they really try to trick you up here. They love to throw these problems in here. They're trying to get you. They're trying to catch you and say, oh, everything in the parentheses receives the power, like the power rule in the laws of exponents. And they're trying to get you to say, well, isn't that 2 squared, which is 4, x squared, plus 3 squared is 9, and y squared, that is the wrong answer, okay? You've got to multiply that out the long way, no shortcuts. Remember, we can only take the shortcut in the power rule when it's a monomial, that's a binomial. And then you're going to have one big one, a trinomial times a trinomial. Okay, problems 1, 2, 3, 4, there's the answers to those. In a moment here, you can pause, you can work on these, you can come back to it. But again, if you have any questions on those problems, you can get online and chat and work with the tutors. There's one division of polynomial problem from section 4.8. Please review the lecture that we made last time, whether it says today's lecture. But it was the last lecture that we gave. Very simple. You should be able to handle that. Not even going to put an example up there. Just refer you back to our lecture on 4.8 that we just completed recently. So just for a moment here, let's erase a little bit of this right here, and let's take a moment to talk about 2x plus 3y squared. So I have 2x plus 3y quantity squared. We know that's 2x plus 3y. Just like anything that's squared times itself, 2x plus 3y. Both of these really end up being a binomial times a binomial. So in essence, you will have on the test 3 binomial times binomial problems. This 2x has to go to here and to here, so we will end up with 2x times 2x plus 2x times 3y. 2x times 2x, numbers go with numbers, x's go with x's, we get 4x squared. Again, numbers go with numbers, and then the variables go next to each other. We have plus 6xy. And then this, 3y, also has to go to everything in the second parentheses. This has to go to here and to here. And we're going to end up with plus 3y times 2x, okay, plus 3y times 3y. These will give you, when we put these together, numbers with numbers, 3 times 2, and y times x, which we will call x times y. We've discussed that before. Because we put this as x and y, we want to do the same here so we can identify our like terms. Plus 3 times 3 and y times y. So we end up with plus 6xy and plus 9y times y makes y squared. We have some like terms in the middle. Those combine, we end up with 4x squared plus 12xy plus 9y squared. Don't forget, on binomials times binomials, to go the long way. Go ahead and pause, Nicole. We're back online?
Yeah.
Yes. Okay, well, since Nicole, mija, is muy chistoso, we have a special problem up here. But let's draw our attention over here first. The final thing on the test that you got to be prepared for are the retro questions. And so we have 3 questions that are from Chapter 2 and 2 questions that are from Chapter 3. 2 of the questions are asking you to use the 3-step process to solving. They have equal signs. Here's one that we're going to do. I'm not going to do both for you. I'm going to definitely do one that's like one on the test. And then there's a word problem on the test from Chapter 2. And this one is about Nicole's boyfriend and his rectangular head. This should be super entertaining. And then in chapter 3, we are being asked 2 questions. One, they want you to find the intercepts of a line. So maybe they have, 2x plus 4y equals 8, and they tell you to find the coordinates, of the x and y intercepts in that order. We've talked about that before. And then, maybe they give you another equation, 3x plus 5y equals 12, and they ask you to graph that line. Okay, so review those concepts. I'm going to erase the left side of the board. We're going to do these 2 problems, and that'll wrap up our review for the Chapter 4 test. One thing I want to tell you before we wrap this up, and I want to be really serious here. Again, no cheating on the test. It's online now. You will have access to it, and you'll have a period of time in which you can take that test, and then you know that you can retake it. You are not to use notes. You are not to use your friends. You're not to use your computer. You're not to cheat in any way. You treat it just like you would as if you were in the testing center. You bring your calculator, a scratch paper that has nothing written on it. You show your work so that you can ensure that you're doing it correctly on your scratch paper. But at the end of the day, you plug your answers in and you do your best and you get what you earn. And then if you don't do well, you can go back and review it. And you can review it as much as you want. The nice thing is that you will have constant access to that test once you've taken it to go back and look at it and rework problems. But this test sets up a little differently. Now that we're in the online world, it recalibrates. And so no 2 tests are exactly the same. Every test will be different in the sense that when you retake it, the problems, the numbers, the answers will be different. But the same concepts, again, number 3, on the test, if you have a laws of exponents quotient rule problem for number 3, it'll be the same for any version of the test. Every version, number 3, will be a law of exponent quotient rule problem. All right, fetchers, again, I just want you to be honest, do your best work, and get what you earn. So I have 1/3 x plus 3/5 x equals 12. If you remember, we get rid of fractions. That's our number 1 rule. And so we have to find the LCD. What is the LCD, Nicole? Do you know? 3 and 5? Yeah, 15. 15. Yeah, speaking of Spanish. Nicole's studying Spanish, and their school's canceled too, so she's been working on her Español. All right, so the LCD is 15. So we're going to have 1/3, and we're going to multiply that by 15, 1/3 x. Okay, plus 15 times 3/5 x equals 15 times 12. Nicole, will you look on your calculator and be working on what is 15 times 12? Because your old man cannot remember that. 15 over 3 makes 5. 5 times 1x is 5x. 15 over 5 makes 3. So plus 3 times 3x is 9x. And 15 times 12 is?
180.
180. The lovely Nicole finding that for us. 5x and 9x makes 14x equals 180. You ready for another computation, Nicole? We're going to divide this side by 14 and divide this side by 14. What's 180 divided by 14?
12.85.
12.85, okay? And if that was given as a fraction, okay, we would have to reduce these two, and in the end, it would really just be 90 over 7, okay? 90 over 7. Okay, and the reason that is because, both these are divisible by 2, all right? These 2 answers are ultimately the same depending on what they give you on the test. They're not going to have a problem that works out like this. It'll be nice and clean for you. This one was a little gnarly because I made it up, but there's a problem like this on the test. Nicole's boyfriend has a rectangular head. This is true. Most of our heads are kind of rectangular, but kind of oval, right? Okay, the length is 24 centimeters more than the width. The perimeter is 128 centimeters. We talked about this. This is a geometry problem, right? Because we're dealing with rectangles. That key word there, rectangle. And another key word, perimeter. So perimeter equals 2L plus 2W. I told you a long time ago that they love to use comparison statements. And so here it is. The length is 24 centimeters more than the width. That is your comparison statement. The length is L. Is means equals. 24 more than, 24 plus the width W. Okay, we know what P is because it says P is 128 centimeters. So we have 128 equals, L is 24 plus W, so I have 2 times 24 plus W, plus 2w. 128 equals 2 times 24 is 48. 2 times w is plus 2w, and you have another 2w. Here I have 128 equals 48. You ready, Nicole, for some more arithmetic here? 2w and 2w are my like terms. I have 4w. I'm going to subtract 48 and subtract 48. I believe that that is going to give me 80.
Yes.
80 equals, these cancel, 4w. Dividing by 4, dividing by 4, and w equals 20. So the width of his head is 20 centimeters, all right? Which means that the length is 20 plus 24, the length is 44 centimeters. Just for fun, you ought to get yourself out a ruler, check out centimeters, and check out what a 20 centimeter wide, 44 centimeter long head looks like. I don't know, could be huge, could be small, could be something fascinating. You guys, good luck on this test, and I'll catch you on the next lecture.
Pause.
Stop.
Stop.